Hello friends, in this video we are going to learn linear programming problems. How the linear programming problems solved by graphically method. Here is a different types of linear programming problem. First is a paragraph wise, which the constraint, the objective function and constraint we have to create equations. Second, the directly equations given, it will give, then we have to solve that by graphically. This one first we have to make the question, then solve by the graphically method. Okay, let's study the question by following the step easily solve. We can easily solve the linear programming problem LPP. A chemical firms produce automobile cleaner X and polish Y and realize profit rupees 10 on each batch of X and rupees 30 on Y. Okay, X pay on X it's a 10 rupees profit, on Y it's 30 rupees profit. Both products requires processing through the same machines A and B. Both the products are passing through the same machine A and B, but X require 4 hours in A and 8 hours in B, whereas Y requires 6 hours in A and 4 hours in B. During the forthcoming week, machine A and B have 12 and 16 hours of available capacity respectively. Okay, assume that demand exists for both the products. How many batches of each should be produced to realize the optimal profit Z? Profit means this problem is the profit should be always maximized, so this problem is for maximization case. First, what we have to do, we have to make some working notes. For example, okay, there is a two product X and Y and two machine A and B. So write machine solution machine A, machine B, and X, Y, both the products. Okay, where it is profit 10 on each batch of X and 30 on Y. Profits how much? We can write profit here also, no problem. Okay, but on X and Y means it's given directly, so not in A and B machine, so we have to write here only. Total overall profit of X is 10 and Y is 30. Okay, now for this purpose both the product requires through the same machines, okay, processing through the same machine, but X required 4 hours in A and 8 hours in B. So how much? X require 4 hours in A and 8 hours in B, whereas Y requires 6 hours in A and 4 hours in B. Y how much? Six hours in A and 4 hours in B. Okay, but after that, during the forthcoming week, machine A and B have 12 and 16 hours of available. Machine A and B, how many hours of available? Okay, 12 for A, 16 for B. This much hours available hours. This is the working note. First, what we have to do for creation of constraint and objective function? First we have to step 1 for making equation. Okay, first the key decision, the main thing what we have to do, the key decision is to minimize. Here is a maximize the profit. The key decision is to maximize the profit. Then step 2, let x and y are decision variables of machine A and B. Then go for step 3. Profit on A. Here profit on X, 10 on Y, 30. So we can create now here objective function. Profit means max is equal to 10x. We can say x1 x2 also, otherwise x and y also, no problem. Okay, if you take the x1 x2, that is also better, or else this one also better, no problem. This is the objective function. Now we have to prepare constraints. Step 4. Step 4, subject to constraint or constraint. And constraint. How we can make the constraint by seeing the problem. Look for first x1, xy 12, 8, 6, 4 and 16. Always remember in maximus case, first one how much? 4 and 6, 12. X 4x plus 6y less than equal to 12. Why less than? Always whenever the maximum means profit, wherever is the profit, the less than symbol should be appeared. Okay, for the purpose of minimization case, the greater than symbol will be appeared. Okay, the second one, y is appeared means this profit should be greater than 12, the overall availability hours. And 8 and 4, the second constraint is 8 and 4, 8x plus 4y less than equal to 16 hours available, and the decision variable x comma y is greater than 0. They should be greater than 0 because we should have to get the profit. Now formulation of step 4. We can also say this one non-negative function, step 5. We can create this one as a step 5 non-negative function of this one, x1 and x2, non-negative function. We can make it step 6, formulation of LPP. How we can formulate? Max. What is the objective function? 10x plus 30y, 10x plus 30y STC 4x plus 6y less than equal to 12, 8x plus 4y less than equal to 16. Now x variables are xy greater than equal to 0. This is the formulation of LPP. Now we have to start the graphical procedure. How we can do the graphical procedure? First, we have to convert these equation into standard form. Okay, means equality equation, inequality equation into equality. Step 6. If the directly LPP is given, means the question is given, we have to start from this one. Standard form means equality, conversion of inequality converted into equality. If it is given from like a paragraph, we have to create this one. Okay, inequality into equality. Into equality. Means standard form. Okay, how we can convert? Like 4x plus 6y is equal to 12, 8x plus 4y is equal to 16. This is the conversion standard form. Here what we have to do, we have to calculate. Okay, how we have to calculate? I will show you an easy method. We have to calculate the points. Okay, this is for 4x plus 6y into 12, this one equation, and this is for 8x plus 4y into 16 equations. Okay, so now we have to prepare a points, okay, to draw a graphical. How we can do? So So look at here, if you put 0 here in x, this is for x, this is for y. Okay, if you put 0 here in x, then there is only y. So what you do, bring 6 into don 12, then 12 divided by 6 is 2. Okay, and in second time put 0 in y, then what you have 4 only. This y is no, you don't have, you have only 4x. So what you do, like the first equation, if you have 4 0 plus 6y into 12, what do you do, 6y is equal to 12, then y is equal to 12 divided by 6 is equal to 2. Same as here also. Okay, if it is 0 means x is there only, 4 should be come into the down of the 12, then what is the, it's 4 3 is 12. This is the two extreme point of, this is the first point, this is the second point. Now for the second equation, put 0 in here. Okay, we have only 4, so 4 goes in the downsides, so 16 divided by 4 6. First putting 0 here in x, here 4. Now put 0 here in y, so 8 by defaultly it come into the 16 now, then how much is 2. Okay, like x 0 plus 4 y is equal to 16, then 4y is equal to 16, then y is equal to 16 divided by 4. Like the same things I have taken. Okay, so we got the points. Now what we have to see, we have to go for graph. Okay, now we have to go for graph. Let's draw a graph. Take a graph with you. I have a graph here. Okay, this is the graph. Okay, we don't have much values here, only 1 2 3 4, so we will take in 1 2 3 4. Okay, so I'm preparing one graph here. Okay, so this is the graph I'm preparing. Okay, let's take, so 0.5, so otherwise 1 2 3 we can also take 1 2 3 4, no problem. Take 1, this here is 0, this is the y-axis. Okay, sorry, make it x-axis, here make it y-axis. 1 2 3 4 5 6 7 8 9 10. Okay, here is a 1 2 3 4 5 6 7 8 9 10. Okay, now first point, what is the first point we got? We got the first point for the first equation 0 comma 2. On x it is 0, on y it's 2, means on x it's 0, but on y it is 2 here. Okay, and the second, on x it's 3, on y it's 0. On x it's 3, on y this is the y line 0. Y 0 means here is 0, but x is a 3 means here is a 3. What you do, we will create one point here. Okay, this is the point we have created. Now go for second equation. X is 0, y is 4. Okay, here x is 0, but y is a 4, and x is 2 and y is 0. Here this x is 2 here, but y, this y is 0 means here, but x is 2. Here is a point. So now drag this line, okay, both are the less than means all lines should be downside. Here is a attaching point. Where is touching, where is interacting, and this point is first we have taken this 0, okay, 2 comma 0 comma 2. Okay, this one 3 comma 0, this one 0 comma 4, this one 2 comma 0. Okay, this is where we have taken for 4x plus taken from 6y greater than equal to 12, and for this one what we have did, 8x plus 4y less than equal to 16. Where is interaction? It's in x and y 1.5, x 1.5, sorry, in x 1, in y 1, x1 y1. It is interacting x1 and x is a 1.5 here and y also, but y is the 1. Okay, this is the one line, but x is 1.5 line. So where it is interacting, x is 1.5 comma y is 1. Okay, so now we have to solve here. We have identify a feasible solution. The extreme point, what we have got, the extreme point means the point, this is the inner column point. This is known as extreme point. This is the inner column points. It's touch here means this is the only inner side. Okay, so write the extreme point here, 0 comma 2, first, another one, second, 1.5 comma 1, third here 2 comma 0. Okay, if you can't find, you can see like this, 2 comma 0. This is 1.5 comma 1, 0 comma 2 here. Now here also we have to take, means this is 0 comma 0 always, x and y 0 0. So take this one also 0 comma 0. Now another point is over. Okay, so what we have to do, we have to now find the value of z. Okay, how we can find the value of z. How we can find? Objective function is 10 and 30. Objective function is 10x plus 30y. So add in this here, in these points here, 10 in place of x take 0, plus 30 in place of y take 2. This is 0, this is 60. Answer is 60 here. Now here take x. This x means 1.5 plus 30. Here is a y is a 1. So this one is a 15 plus 30, 45. Now 10 2 plus 30 0 is a 10 20 the, sorry 2 is not 20, 2, 10 to the 20 plus 0. Answer is 20, sorry 20. Now go for this one, 10 into 0 plus 30 into 0, 0. So what is the maximum one? 60. 60 is the maximum value here. Okay, thus if 0 against among the above value, the maximum value of z is obtained at how much? There we have obtained 0 comma 2 is the maximum value. This is how we can solve the LPP by graphical method. In the next video of LPP, I will showing you some different like if there is a less than, greater than, much. Watch another video for more clear understanding, and another one also I'm going to show you.